In this tutorial session, our task is to show that the variance of the random variable x in the Bernoulli distribution is equal to PQ. So this will be our task in this tutorial. So we want to show that the variance of a Bernoulli random variable x is equal to PQ. Now recall that the PMF of a Bernoulli distribution can be written as the probability of x is equal to small x, which is equal to p to the power x 1 minus p to the power 1 minus x, where x runs from 0 to 1. Okay. And now, because s runs from 0 to 1, this implies that if you sum the PMF from 0 to 1, it can be written as p of x is equal to 0 plus p of x is equal to 1. So I'm going to use this a lot, so kindly take note of that. Now recall that the variance of a random variable x can be written as the expected value of x squared minus the expected value of x all squared. We've been able to show that the expected value of x is equal to p in the previous lecture. So now the only problem here is to compute the expected value of x squared. So for the expected value of x squared, it can be written as summing the PMF from 0 to 1, s squared multiplying the PMF, where x runs from 0 to 1. This implies that the expected value of x squared can be written as s squared by p of x is equal to 0 plus s squared by p of x is equal to 1. I hope you know the reason why we are writing it this way. Okay. So it implies that at this section of the equation, we are going to substitute 0 and we substitute 1 here. Okay. This implies that the expected value of x squared can now be written as 0 to the power 2 p to the power 0 multiplying 1 minus p to the power 1 minus 0 plus 1 to the power 2 p to the power 1 multiplying 1 minus p to the power 1 minus 1. Okay. Now, because you are multiplying 0 by this whole expression, it means that this whole expression tends to 0. So you have 0 plus 1 to the power 2 is 1, p to the power 1 is p, and we have 1 minus p to the power 0. Now 1 minus p to the power 0 is 1. Okay, any number raised to the power 0 is 1. So it means that the expected value of x squared is equal to p. So now that we've been able to find the expected value of x squared, we can easily find our variance. Now recall that our variance is equal to the expected value of x squared minus the expected value of x all squared. We've been able to show that the expected value of x squared is p, and the expected value of x is as well p. But here we have to square it because of the condition. So we end up getting 1 minus p squared. P minus p squared Alright, so we have var of x, which is equal to p minus p to the power 2. Now let's factor one of the p's out. We have p 1 minus p. Okay, now recall that 1 minus p is equal to q. I hope you remember this. 1 minus p is equal to q. Is the failure probability. So it means that we can actually write this as pq. So it means the variance of x can be written as pq. So we've been able to show that the variance of the random variable x in the Bernoulli distribution is pq. Now note that this is only possible when x runs from 0 to 1. Alright, so folks, I hope this video was helpful. If you're not subscribed to our channel, kindly do what to subscribe. And don't also forget to press on the bell icon so that you don't miss any new updates from Co-Prime Statistics. Thank you very much for watching.